In this video, we are going to be dealing with the West African Examination Council. Precisely, we'll be doing a revision on the West African Senior School Certificate Examination Chemistry Paper 2. I'll be starting with Part A. But before we continue, my special gratitude goes to myschooljist.com for making available to us the question paper. However, I want to thank those of you who have taken your time to subscribe to my channel. But for those of you who haven't subscribed to my channel, please like this video, share to other learners, and most importantly, take some time and subscribe to the channel so that other papers that we are going to be solving will be coming directly to you. Thank you once more for taking your time to subscribe to our channel. Let's get started. West African Senior School Certificate Examination 2000. That's the 2000 exam. We are starting precisely with Part A, Objective Tests. Answer all the questions. Each question is followed by 4 options lettered A to D. Find out the correct option for each question and shade in pencil on your answer sheet. The answer space which bears the same letter as the option you have chosen. Give only one answer to each question. An example is given below. Which of the following pairs of substances will react when mixed? Ethanol and water, ink and water, palm wine and water, sodium and water. The correct answer is sodium and water, which is letter D, and therefore answer space D would be shaded. And answer space D is how it is being shaded. Think carefully before you shade the answer spaces. Erase completely any answer you wish to change. Do all rough work on this question paper. Now answer the following question. Question number 1. If an atom of an element is represented as 40-20Y, that is 40, the mass number 40 and the atomic number 20 of Y. This shows that it has A, 40 neutrons, mass number 20, 20 protons, atomic number 40. Fellow learners, for the purpose of revision, have this. Remember that if an element is an element, X has the mass number, or what we call the nucleon number A. It has a proton number Z, which is also called the atomic number. This is the mass number, A is the mass number, and Z is the atomic number. In other words, it is the nucleon number or the proton number. It should be noted that The proton number plus the number of neutron will give you the nucleon number or the atomic mass. So if given the proton number or if given the atomic number to look for the number of neutrons, it would be the mass number, which is also called the nucleon number, minus the proton number or the atomic number. You have the number of neutrons. So the number of protons is equal to the Z, which we have given here. So if given the number of neutrons, to find the proton number, it will be the proton number, it will be the atomic mass, or what we call the nucleon number, minus the number of neutrons. You will have the proton number, or what we call the atomic number. So let's get back to our question. You have been given the mass number, or what we call the nucleon number, and you have also been given the proton number, or what we call the atomic number. Now, this is the atomic number, this is the mass number. What we don't know here is the number of neutrons. The number of neutrons here should be what? The number of neutrons here should be 40 minus 20, which is also 20. The number of, it should be remembered that the proton number or the atomic number is equal to the number of electrons. So 20 is equal to the number of electrons. So our answer here for question number 1, our answer here for question number 1, 20 is the proton number, 20 is the number of electrons. So now, A is 40 neutron, no. B is a mass number, which is the mass number, no, which is 20, no. C is 20 is the number of proton, 20 proton. So C is our right answer. We have to share it. C is our right answer. We need to share this one. C is our right answer. So C, we have to share C as our right answer. Question number 2. When metals react, they usually do so by what? Metals, for the purpose of revision, metals, we are talking of group 1, group 2, and group 3. What they do is that to have a stable outer electrons or outermost electron, they will lose electrons. So metals react by losing electrons, losing their outermost electrons. When they lose their outermost electron to the non-metals, they obtain a stable outermost electron. And that is how they do, and that is how they react. So when metals react, they usually do so by what? A, gaining electron, no. B, sharing electrons, no. C, donating electrons, donating electron pair, no. And D, losing electrons. D is the right answer for 2. So we need to share it. We need to share the answer space. Question number 3. If the mass number of X is 24, if the mass number of X is 24, and X2 plus, the X ion, that is X2 plus, contains 10 electrons. The nucleus contains 10 electrons. If the mass number is 24, and the ion, which is X2 plus, contains 10 electrons, the nucleus of X will consist of what? It should be noted that this is the mass number, which is 24. This is the mass number, which is 24. And the ion, which is X2 plus, contains 10 electrons. If the ion if the ion which is H2 plus contains 10 electrons, H2 plus shows that 2 electrons has been lost. Then initially, that means the number of electrons there were 12. If it's 2 X2 plus and it contains 10 electrons, the nucleus of the atom, will consist of what? The nucleus of the atom will consist of, so remember that this was 2 electrons. 2 electrons have been lost. So if we added this to this, it's supposed to be 12 electrons initially. And 12 electrons is equal to 12 protons. So the nucleus of the atom is supposed to have 12 protons. And if this is the mass number, which is 24, protons plus the neutrons will give the mass number. Therefore, the number of neutrons that are supposed to be in the nucleus are also 12, because 12 neutrons plus 12 protons will give us 24. So the is supposed to have 12 protons, 12 neutrons. And let's see if the answer is like that. A, 8 protons and 16 neutrons. It doesn't work like that. B, 10 protons and 14 neutrons. It doesn't work like that. C, 10 protons and 12 neutrons. It doesn't work like that. D, 12 protons and 12 neutrons. Excellent. D is our answer. Three is D. 4. The atom and the ion of chlorine have the same atom and ion of chlorine have the same what? Remember, an atom of chlorine and the ion of chlorine. Chlorine has lost an electron. Chlorine has gained an electron. In that case, the atom and the ion will not have the same number of electrons. But they will have the same number of what? They will have the same number of protons and neutrons. Okay, the atom and the ion of chlorine have the same number of proton, electronic configuration, chemical properties, electrical charge. They will have but the same number of protons. Our answer is A. 4 is A. 5. Element X has 2 electrons. Element X has 2 electrons in its outer shell, while element Y has 6 electrons. X has 2 electrons in its outer shell, while Y has 6 electrons. Y has 6 electrons. The compound formed between X and Y has what? For element X to have 2 electrons in its outer shell, it shows that in the outer shell, it shows that element X belongs to group 2 of the periodic table. And if it belongs to group 2 of the periodic table, let me do some work here for you. And if it belongs to group X of the periodic, group 2 of the periodic table, okay, precisely, X has 2 electrons in its outer shell. That it has in the outermost shell, in the outer shell, it has 2 electrons. It means that X belongs to group 2 of the periodic table. This is X. It belongs to group 2 of the periodic table. And all group 2 of the periodic table, they have a charge of +2. Element Y has X electron, has 6 electrons in the outermost shell. It shows that with 6 electrons in the outermost shell, it belongs to group 6 of the periodic table. And if there are 6 electrons in the outer of group 6 element will require 2 electrons. They will gain 2 electrons to complete the octet of electron. They will require 2 electrons to complete their outermost shell to be 8. So Y will have -2. Now, This and this, they can cancel each other. This plus 2 and minus 2 can cancel each other. So now the bond formed between these will only be X and the Y. Okay, let's go there and see how it goes. And let's get back to work. Now our answer is A for question number 5. Our answer is A for question number 5. Let's get to question number 6. Electron will occupy equivalent orbital singly. Electron will occupy equivalent orbital singly as far as possible with the same spin. That is, if they are spinning upward, they will have. If they are singly, if they are singly occupying an orbital, they will be spinning but upward. Now, if they are pairing now, the next electron in their pairing will be spinning downward. So they say electron will occupy equivalent orbital singly as far as possible with the same spin. Is a statement of which rule? Hooke's rule, Pauli exclusion principle, periodic law, Obo principle. Which of the rules? It is Hooke. See what Hooke is telling you here. According to Hooke's rule states that. See, according to Hooke's rule states that every orbital in a sublevel is singly occupied before any orbital is doubly occupied. We are saying that every orbital, in filling the orbitals, you must first of all put one electron in the orbitals before putting it a single one. All of the orbitals, all of the electrons in singly occupied orbitals have the same spin. For instance, see what we mean. We have how many electrons here? 1, 2, 3, 4, 5, 6, 7. There are 7 electrons here. We want to write or want to use electron in orbital in filling electron in orbital in writing it. Now the first energy level, which is 1s, is supposed to be 1s2. We will fill it 1. Since it's only 1, we will say the spinning is opposite and the other one is opposite. They are spinning in opposite direction, 1 and 2. The first one should be up and the second one is down. Now we go to the second energy level, 2s. 2s is supposed to be 2s2. Now, the first one will go up and the second one will go down. How many from 7? How many electrons have we used? We have already used 4. We are now left with 3 electrons. Now, on the same second energy level, that's the 2s and now the 2p orbital now. The 2p is divided into 3 suborbitals. This one is x, y, and z. And each of them has 2 electrons. So, because in order to fill this, we cannot start and be saying that it is up and down, up and down. So, whose rule said that every orbital in a sub-level is singly occupied before any orbital is double. So, the first thing is we must first fill them in singly. Each of the orbital must first of all be filled singly. Only one electron should be filled there before pairing it. So we start this with 1 and it is spinning but upward. 2 and it is spinning but upward. 3 and it is spinning but upward. That is what Hooke's rule states. That is the application of Hooke's rule. It is not this way. The first shell have been filled. The second shell, we will not do it this way. Filling it the first shell by putting the first one and putting the and doubling it and pairing it. No. We take by the first one. First of all, fill them singly before pairing it. So the first one is how the Hooke's rule is applied. And that is the same thing here. The same thing, that is how it is applied here. And that is why this question is saying that electron will occupy equivalent orbitals singly as far as possible with the same spin. With the same spin is a statement of Hooke's rule, which I've just explained. So our answer is A. Question number 6 is A. Question number 7. M is group 2 element. Which of the following represent the ionization of its chloride? Ionization of its chloride. A group 2 element, for being a group 2 element, this is what will happen. For being a group 2 element, and a chloride. This is group 2, this is M, and the chloride, this is a chloride. A group 2 element has a charge of a +2. A chloride is a halogen, group 7. And the group 7 would gain 1 electron to complete the octet. So it has a charge of -1. So in this case, the simple way of forming a compound between the two is that we will swap their, we are going to swap their numbers. We are going to swap these numbers. 1 will come here and 2 will come here. And the compound formed between these two will be what? The compound formed between these two is M. M is 1. This is just 1 here. Then chlorine is what? Chlorine will collect these 2 from here. Will be Cl2. So this is the compound that will be formed between these two. And this compound, when it dissociates, is going to give 2 chloride ion. So let's see which compound is MCl2. MCl2 is C. MCl2 is C. So if we are to base our answer for question number 7, our answer for question number 7 will be C. Yeah. Okay. That's the ionization of the chloride, of its chloride. Question number 8. Which of the following forms a coordinate covalent bond with a hydrogen ion? What is a coordinate covalent bond? A coordinate covalent bond, this is when one atom contributes 2 electrons for the bonding. The 2 electrons that are used in sharing, the 2 electrons that are used for the sharing are contributed or are donated by only 1 atom. So here, which of the following forms a coordinate bond with hydrogen? It is not carbon dioxide, it is not oxygen, it is not nitrogen, but it is oxygen. It is water, and this is how water forms it. Water has a V shape. H2O, and here on the oxygen we have a double bond here. Even though there is another double bond here, there is this double bond here. But the hydrogen ion has no electron in it. So it will need to bond on this hydrogen, on this lone pair of electrons. And that will result in this compound here. So there is that's why the movement of the lone pair of electron here to hydrogen ion. So it is water. Our answer for question number 8 is C. Question number 9. Question number 8 is C, as I said. Question number 9. Question number 9. How many electrons are present in the 2p orbital of an element represented as 19 and 9? 19 mass number and 9 mass 19 mass number and 9 the atomic number. Okay. In the p orbital, how many electrons are in the p orbital? Now, in the p orbital, let's write it right now. For question number 9, we have, there are 9 electrons here. Atomic number, which is 9, is equal to the number of electrons. So we are going to write for 9 electrons. The first energy level is 1s2. So 1s2, we fill it with 2 electrons. We fill it with 2 electrons. Now we are going to the second energy level. That is 2s, 2s and 2p. For 2s, we must first of all fill the first 2, as I told you in the Hood principle. Then now, for the 2p, 2p is higher, a bit higher above 2s, even though all of them are of the same energy level. But this one, 2p, is a bit higher up. So with 2p, there are 3 sub shells. There are 3 of them, 1, 2, and 3. And each of them must contain at most 2 electrons. So we have filled the first 2 orbitals, and from 9, 4 electrons have been used. So we are now left with what? We are now left with 5 electrons to fill here. We first fill it, as I told you, according to Hooke's principle, we have to fill 1 in blue. All of them must be singly filled. Then now we start pairing it. We have this pairing and we have this pairing. In total, how many electrons are in the 2p orbital? We have 1, 2, 3, 4, 5. There are 5 electrons there. And if we go there, if we go to the answer column, for number 9, 5 is D. Question 9 is D. We go to 10. The emission of a beta particle from the nucleus. A beta particle from the nucleus of a beta particle from the nucleus of a radium, that is 22.6. The mass number is 22.6 and the atomic number is 88, will produce A, B, C, and D. Okay, a beta particle contains what? This is how a beta particle is represented. This is how it is represented. Here, we will have, in a beta particle, this is how it is being represented. We will have, let me just show it there before we go to the question. Let's say an element X undergoes a beta emission. There is a nuclear reaction taking place, and it emits beta particles. So this is the beta particles. The mass number of beta particles is 0, and the atomic number for the beta particle is -1. So now the element X has the mass number A, it has the atomic number Z. Now, if he has to undergo a beta emission during this nuclear reaction, what will happen is that the beta particle that's going in the atomic, the mass number will remain unchanged. The mass number remain unchanged. The atomic number will increase. The atomic number will increase by 1. Oh, there was an error here. The atomic number will increase by 1. The atomic number will increase by 1. Atomic number increases by 1. The atomic number increases by 1. The nuclear charge, if there was a nuclear charge of X, will remain unchanged. So the atomic number will usually increase by 1 when it is undergoing a beta decay. So that's why I say the mass number will remain unchanged. The atomic number will be X plus 1. It will increase by 1. when it undergoes this. So going back to our question, going back to our question, you will see that this is 22, 6, and 88. The mass number remain unchanged, as we said. Then the mass number remain unchanged, as we said. But what will change will be the atomic number. Atomic number will increase by 1 because it will be 89. Why do I say the atomic number will be 89? From this value here, it is minus, since it is undergoing a beta rule, a beta decay. It is minus, and the beta is a negative 1. It is minus 1, which is a plus. It is, since it is undergoing, it is beta emission, we will say minus, then the minus, which is the minus 1, which is in beta, will give us a plus. And that's why we say it will increase by 1. So our answer will be 89 for atomic number. Let's see where there is 89 for atomic number. Where there is 89 for atomic number, 89 for atomic number, our answer for question number 10 will be A. 89 for atomic number. Okay, we now go to question number 11. Our question number 11 is has to do with some other concepts. Question number 11 is, which of the following represents correctly the arrangement of particles during double decomposition reaction? Fellow learners, it should be recalled that another word for double decomposition is double replacement. Double decomposition, because they said a double decomposition, another word for double decomposition is double replacement. So now, for double replacement or double decomposition, you have seen that. Let me give you a clue on that. Let me give you a clue on that. Double decomposition is a double replacement. I gave you an example of silver nitrate reacting with silver chloride. Silver nitrate reacting with silver chloride, we will have a white precipitate of silver chloride and the silver nitrate. Why do I say so? Come here. Silver replaces, that is Ag, will replace the sodium here. And the sodium again is going to take the place of, the sodium again is going to take the place of silver. Here with nitrate, silver is replacing the sodium is replacing the silver in the nitrate. Meanwhile, in the chloride, the silver is now taking again the place of the sodium. I took another example for neutralization reaction. That is the precipitation reaction, and this one is a neutralization reaction. For neutralization reaction, acid and alkali. Sodium chloride, hydrochloric acid, dilute hydrochloric acid, and aqueous sodium hydroxide. Hydrogen is taking the place of sodium to form a molecule of water. That is, so hydrogen will react with this one to form water. And again, sodium is now replacing the hydrogen in the chloride to form the sodium chloride. So this is what we call double replacement. Double replacement. And if we use this concept of double replacement or double decomposition, if we come here to our answer column, we will see that P has replaced, let me see whether P has replaced S. Has S replaced P? No. Okay, P has replaced arrow. But P has replaced arrow, Has S replaced, has R replaced P? Let me see. It's not the same way. It's supposed to be PS and RQ. So that is not the thing. Go to C. P has, let's see whether P has replaced S. Yeah, P. So it's not a thing. Let's go to D. Let's say P has replaced arrow to be PS. Yes. And R has replaced P to be RQ. Excellent. So this is where the answer is lying. Our answer is D. Again, you go to question number 12. Two cooked vessels of different capacities contain 0.01 mole each of gas X and Y. 0.01 mole each of gas X and Y. Maintained at the same temperature. Which of the following will be the same for X and Y? Which of the following will be the same for X and Y? A. Pressure exerted by the gases. B. Frequency of collision of their molecules. C. Number of molecules present. It has to do with volume. Two cooked vessels of different capacity contain 0.01 mole of the gas X and Y, maintained at the same temperature. Which of the following will be the same for X and Y? It has the same vessel, pressure exerted by the gases, frequency of collision of the gases for the molecules, number of molecules present, molar mass of the gases. Okay, if we look at this law, equal volume of gases concern the same number of molecules. Equal number of equal volume of gases concern the same number of, they say two cooked vessels of different capacity contain 0.01 each of these at this. So equal number of volume for the gases will contain the same number of molecules. And in that case, if they are containing the same number of molecules, I will say the answer is C. They are equal, they will contain the same number of molecules. Yeah, let's go to question number C. Is for question number 12, C is the right answer. Question number 13, excuse me. Question number 13. For question number 13, a given volume, for 13, a given volume of oxygen diffuses. A given volume of oxygen diffuses through a porous plug in 8.0 seconds. How long will it take the same volume of sulfur 4 or sulfur dioxide to diffuse through under the same condition? Once more, a given volume of oxygen diffuses through a porous plug in 8 seconds. How long will it take the same volume of sulfur 4 oxide, that is sulfur dioxide, to diffuse through under the same condition. Okay, there are two gases. We have oxygen and we have sulfur dioxide. That's right. Oxygen and sulfur dioxide. Okay. It's a simple thing we have to do. There are two gases. Oxygen is 16, but oxygen is a diatomic. That's why the examiner is being trickish. He did not put the O2 to be 32. So oxygen is diatomic, so it is 16 times 2, which is 32. But sulfur dioxide is full here, is 64. So now, let's see our calculations. In the calculation, it should be recalled that oxygen is 32 gram per mole. Sulfur dioxide is 64 gram per mole. Assume that diffusion is at room temperature and pressure. If 1 mole of a gas at room temperature and pressure occupies 24 dm cube of volume, we will now say that all of them are 1 mole, 1 mole. This is 1 mole. A diatomic molecule of oxygen is 1 mole. This is also 1 mole. That's why we say 32 gram per mole, 64 gram per mole. So we now say if 24 dm cube of 32 gram per mole of oxygen, that is 1 mole, diffuses, if 1 mole of oxygen diffuses in 8 seconds, then the same 1 mole of oxygen, which is 24 dm cube, then the same 1 mole of sulfur dioxide, which is 24 dm cube, and carries a mass of 64 gram per mole, will diffuse in how many seconds? Or in other words, you can ignore this volume occupied by this by the 1 mole of all the gases. You can just say if 32 gram per mole of oxygen, that's 1 mole of oxygen, diffuses in 8 seconds, then 64 gram, which is still 1 mole of sulfur dioxide, will diffuse in how many seconds? You do the simple proportion and our answer will be 16 seconds. It is 16 seconds. Method number 2, I want to support this. I want to support the answer for this. The answer for this, it is 16 seconds. Why I say it is 16 seconds? Because the mass of oxygen diffused for 8 seconds, and the mass of oxygen was 32 grams per mole. Then the mass of sulfur dioxide is 64 grams per mole. It will take a longer time to diffuse. In other words, Graham's law of effusion states that gases, the diffusion of gases depends on the mass or the molecular weight of the gas. Gases with low molecular weight will diffuse faster than gases with high molecular weight. Or in other words, gases with high molecular weight will diffuse very slow, will take a longer time to finish the diffusion. Meanwhile, gases with low molecular weight will diffuse very fast and take a shorter time. That is what is applying here. 32 will take only 8 seconds. Then 64 will take 16 seconds. Let's go to our answer column and see if we can have 16 seconds there. Our answer for question number 13 is D. Now let's go to question number 14. The number of hydrozonium ion present or produced by one molecule of an acid in aqueous solution is known as its the number of hydrozonium ion, the number of hydrozonium ion produced by one molecule of an acid in aqueous solution is known as its, it is not its concentration, is known as A, basicity. Yes, it is the basicity. It's not acid strength, it's not pH, it's not concentration. It is its basicity. That is just the answer. 14 is basicity for hydrozonium ion. 15. Consider the following equation. Sodium plus water would give us an alkali, that is sodium hydroxide plus hydrogen. Yes. Calculate the mass of sodium required. The mass of sodium required to produce 0.4 gram of sodium hydroxide. Calculate the mass of this sodium that is required to produce this alkali, sodium hydroxide. Let's go to our calculation box. Now, we have been told that the mass of sodium hydroxide is what? The mass of sodium hydroxide is 0.4. So we can use that. Use this equation here, the mass, moles, and the formula or atomic mass. So now, the moles, the moles of sodium hydroxide will be what? The moles will be mass divided by the atomic mass or by the formula mass. Okay, now, moles of sodium hydroxide will be the mass given divided the molecular mass. So it will be 0.4. And for sodium hydroxide, the molecular mass is 40. So 0.4 divided by 40, our answer will be 0.01 moles of sodium hydroxide. That's right. Okay, using the step number 2, using the equation. We want to use the equation. Using this equation, the fellow learners in your exams, equations that are being given when it has to do with stoichiometry or calculations are very, very important. Balanced equations are very, very important in your calculations. Do not ignore them. So now, using the equation, if 2 moles of sodium can produce 2 moles of sodium hydroxide, then how many moles of sodium will produce the moles that we just calculated? If these 2 moles here can give 2 moles here, how many moles of this one will give the number of moles that we calculated? Let's go back to our calculation. Step number 2. From the equation, if 2 moles of sodium can give rise to 2 moles of sodium hydroxide, that's from the equation, then the calculated moles was 0.01. Therefore, X moles of sodium will give 0.01 moles of sodium hydroxide. Our value of X will be what? 0.01 times 2, cross multiply, and make X the subject, divided by 2. Our number of moles of sodium will be what? 0.01 moles. We have 0.01 moles of sodium. Now, going back to the calculation, to our formula triangle here, to have the mass here will be what? Moles times the atomic mass or the relative or the molecular mass. To have the mass of any substance, you will multiply the number of moles by the molar mass. Okay. But mass is equal to moles times relative atomic mass or the molar mass. And the number of moles we had was what? 0.01. 0.01 times the relative atomic mass of sodium is what? Is 23. We multiply by 23. Moles cancel per mole. So 0.01 times 23 will give us what? 0.23 gram of sodium that is required. Let's go to our answer column and see if we can have this answer there. 0.23 for question number 15. 0.23, question number 15. And 0.23 there is Our answer for question number 15 is A. That is it. Question number 16. In which of the following reaction is hydrogen sulfide behaving as an acid? Is behaving as an acid. Which of the following is hydrogen sulfide? Is hydrogen sulfide behaving as an acid? Okay, what is an acid? What is an acid? Is behaving as an acid. An acid is a proton donor. That is the basic we know about an acid. It's a proton donor when it has to do with this. It's a proton donor. Then secondly, when an acid, when it reacts with a base, salt is formed and a molecule of water. There is salt that is being formed. There is salt that is being formed and a molecule of water. So now, here, it's not acting here like that. It's not acting here like that. This one is not acting here like that. Two acids, sulfuric acid and hydrogen sulfide, is not acting here like that. So the only place that hydrogen sulfide will be behaving as an acid is this one. When it reacts here, it donates all its protons. Here is acting as an acid. Why? It donates its proton to here. It donates its proton here. How is it donating the protons here? It should be remembered. That two hydrogen, the oxygen here will provide a pair of electrons. The two protons will attach themselves there. That's one point. It reacts with this one to form what? Salt and water. That's another point. So in that case, this is the only place where H2S is behaving as an acid. So our answer for 16 is A. Let's go to question number 17. Before we continue, our fellow learners, I want to thank those of you who have taken your time to subscribe to our channel. But those of you who haven't subscribed to our channel, please, the favor we want from you is like this video, share to other learners, and most importantly, take some time and subscribe to our channel so that other subsequent papers that we are going to be solving will be coming directly to you. Thank you. Let's proceed. Question number 17. Hydrogen is evolved when dilute hydrochloric acid reacts with A. Calcium. No. Magnesium ion. Consideration. C. Iron. No. Copper. No. So now it should be remembered that, fellow learners, in the laboratory, for instance, if you take a magnesium ribbon, and put in a conical flask or in a test tube containing dilute hydrochloric acid, what you are going to observe, there is going to be effervescence, or you can say there's going to be bubbles of a gas that are going to be observed, indicating the evolution of a gas. And the gas that is being produced when magnesium ribbon reacts with dilute hydrochloric acid, the gas is hydrogen. And you can test this gas. You can use a lighted you can test this gas. If you test this gas, it gives you a pop sound. So from all this, we can conclude precisely that only the magnesium ion will evolve hydrogen gas when reacted in the laboratory with dilute hydrochloric acid? So our answer for 17 is B. Question number 18. Which of the following properties distinguishes concentrated sulfuric acid? Distinguishes this acid from concentrated nitric acid. What can we use to show that this acid, sulfuric acid, concentrated sulfuric acid, is different from nitric acid? Of course, you should know that sulfuric acid is a very strong acid. It is used in the laboratory for organic reaction. It is also used in the laboratory for inorganic reactions. And for organic reaction, let me say, for alcohols, we can use in alcohols through concentrated sulfuric acid can be used with, let me say, ethanol. Ethanol, you pass ethanol through it, you will definitely see there will be a dehydration resulting in ethane. When ethanol is part of it, resulting in ethane, there's dehydration. A molecule of water is being removed. Meanwhile, nitric acid is a strong oxidizing agent. Nitric acid is a strong oxidizing agent. So we can conclude that ability to conduct electricity on dilution, I don't think so. Ability to liberate carbon dioxide from carbonate. All the gases will liberate it. All the acid will liberate carbon dioxide when reacting with a carbonate. React as an oxidizing agent. Will not react as an oxidizing agent. What will react as an oxidizing agent is nitric acid. Nitric acid is a strong oxidizing agent. But what will distinguish sulfuric acid from nitric acid, from concentrated nitric acid? We are talking on concentrated sulfuric acid. Dehydration of compounds. Exactly. Dehydration of compound is what will distinguish concentrated sulfuric acid from concentrated nitric acid. So our answer for question number 18 is D. It's a D because I said sulfuric acid is a very strong dehydrating agent. Meanwhile, nitric acid is a strong oxidizing agent. Question number 19. Question number 19. For question number 19, consider the reaction, the general equation below. XnCO3, which is solid, and it decomposes on heating to produce XnO plus carbon dioxide, which is a gas. The reaction will not occur when X is okay. To know the metal, the possible metal that cannot be placed here. Okay, looking at the compound, it should be noted that X a carbonate, the carbonate, they have a charge of +2. Carbonate, they have a charge of +2, and X, we don't know the charge of X. But since this is X, and this is a carbonate, this is X, and this is a carbonate. Carbonate, they have a charge of 2 minus. X, we don't know the charge of X. So to know the charge of X, we will know from here, because there's going to be exchange of, let's N, there's going to be exchange of their going to be exchange of their charges. So here we can see that 2 will come here, 2 will come here, and this one is N is 1, N is 1, is 1. Let's say plus 1, N will come here. And in that case, since it is just 1, we don't need to put any 2 or anything here. So it will be X, 2. Any other compound is supposed to be any other compound here. Any other compound here is supposed to be X. It is supposed to be X, either X here is 2 and a carbonate. Implying that the only elements that can form this compound, are copper, that is copper 1, that is copper plus 1, copper plus 1, a copper that plus 1 that has an oxidation number of plus 1, sodium, sodium has an oxidation number of plus 1, zinc has an oxidation of plus 1, but not magnesium. Magnesium has an oxidation number of plus 2. Magnesium has an oxidation number of plus 2. So in that case, it is copper carbonate, copper 1 carbonate. If we are using carbonate, it is copper 1 carbonate. If we are using sodium, it is sodium carbonate. Either we put it like this, it is copper, this is copper 1 carbonate, this is copper, this is the compound, copper 1 carbonate. It is sodium carbonate. It is zinc carbonate. But not magnesium. Not magnesium. So the only element that it will not react with will be magnesium. The only element that will not react will be magnesium. Let me see. Yeah. So back to our question, the only answer, the only question, it will not react. The reaction will not occur when X is C, magnesium. So question number 19, our answer is C. Our answer is C. Yeah. Okay. Let's continue. Question number 20. Why is this thing behaving like this? Question number 20. It's okay. Question number 20. Let me just do some. Question number 20. Which of the following conclusions about a solution of pH pH 4 is correct? Oh, I need to be visible. Which of the following conclusions about a solution of pH 4 is correct? Okay, we have it contains more OH than the H3O plus. The pOH value will be 10. It is more acidic than a solution of pH 2. No. A pH 4 is even weaker than a pH 2. Its hydrogen ion concentration is 4.0 times 10 to the minus 1. If we calculate, let me see, if we calculate the negative hydrogen ion concentration for this, for 0.4, that is 4 times 10 to the minus 1. Yeah, 0.4. And we calculate it, the OH and the pH will be 0.4. It will be 0.4. The pH for this hydrogen ion concentration will be 0.4. For the pH, this is the hydrogen ion concentration. The pH will be 0.4. It's not, nothing is saying here, but they said its pOH value will be 10. Okay, let's use this formula. pH plus pOH is equals to 14. pH plus pOH is equals to 14. But pOH value is 10. If we substitute the pOH value in this equation here, pH plus 10 equals to 14. The pH will now be equal to what? The pH now will be equal to 14 minus 10, which will be equal to 4. And therefore, this one with the pOH value is the right answer. B will be our right answer for 20. Let's seal it. B will be our right answer for 20. B will be our right answer. 20 is B, based on the calculation we have done there. Okay, we are going to question number 21. Question number 21. Question number 21 has to do with energy profile diagram. Which of the following can be deduced from the energy profile diagram below? From the energy profile diagram you see here, A plus B to give AB. The energy level the energy level of the product, the energy level of the product is less than the energy level of the reactant. Therefore, this reaction profile or energy profile is an exothermic reaction. This is an exothermic reaction. This is an exothermic reaction. Therefore, the reaction between A and B is what? Occurring irreversibly. That is not shown. B is an endothermic reaction. C, it is equilibrium. And D, it is an exothermic reaction. I told you that the energy level for AB, the product, is less than that for, if you take the energy level, the corresponding axis here, it is lower than that for the reactant. For that reason, it is an exothermic reaction. So question number 21 is, D. Question number 21, the answer is D. Question number 22. Question number 22, if you look question number 22, you will see that you are going to see that it is has to do with what is a catalyst. Now, the presence of catalyst in a reaction mixture alters the heat of reaction. Catalyst does not produce heat of reaction. 2 or B, the catalyst will do what? Alters the yield of the product. Fellow learners, it should be recalled that catalyst has no effect. The presence of the catalyst in a reaction mixture has no effect on the yield of the product. Instead, the catalyst is there just to speed up the rate of a reaction. It speeds up the rate of a reaction by lowering the activation energy. It lowers the activation energy. It changes the reaction pathway. When it lowers the activation energy, the reaction pathway has been changed. So in that case, like in this case here, when we put a catalyst here, the catalyst, the activation energy is from here to this level. So the presence of the catalyst will help to lower the activation energy. Instead of the reaction coming right up here, it may only be here. It lowers the activation energy. When it lowers the activation energy and makes the reaction to go faster, we say he has changed a reaction pathway. Instead of coming here, he has taken by the alternative pathway. So let's get back to our question 22. It has no effect on heat of reaction. It has no effect on the yield of product. It has nothing to do with equilibrium position. But D, reaction pathway, yes, it alters the reaction. It alters the reaction pathway by lowering the activation energy. When it lowers the activation energy of a reaction, the reaction pathway has been altered. So our answer for this is D. 22 is D. Question number 23. The rate curve below represents the reaction between a fixed mass of sodium carbonate and 0.1 mole per dm cube solution of two acids, X and Y. Of course, we say a fixed mass because the volume of carbon dioxide for the two acids is constant here, because we are using, it is constant here, because we are using a fixed mass of sodium carbonate. Now, diagnosing or trying to interpret our reaction curve, you will see that Y is slow. The reaction rate of Y is slower compared to the reaction rate of X. In other words, X is faster. From the curve, you will see that the curve of X has a steep curve. The gradient here is steep to show that the reaction here is very fast. The gas, the reaction rate here is very fast. Carbon dioxide is collected within a short period of time. For instance, if it is collected after every 2 minutes here, carbon dioxide will be collected here after every 5 minutes. So this one is slow, this one is faster. At the end of the day, they will yield by the same volume of carbon dioxide. So let's go to our question. Which of the following statements about X and the Y is false? False. The rate of reaction, the rate of gas production is the same for X and Y. It is not the same. I said this one, the rate here is faster and the rate here is slower. But at the end of the day, they will have the same amount of gas that will be produced. The rate for A is, the rate for reaction of X is the same for X and Y. No. I will start thinking of A as a false answer. The total volume of the gas evolved is the same for X and Y. Yes, the total volume is the same. For C, X is stronger acid than Y. Excellent. It's a stronger acid. And D, X ionizes more than Y in aqueous solution. Of course, stronger acid will ionize completely than weaker acid. So in that case, the false answer here, which of the following statement is about X and Y is false? The false answer here is A. A is false. A is false. So the answer for A here is false. Our answer for A is false. So let's go again to question number 24. Question number 24. The reaction represented by the equation below occurred in a sealed glass tube. We have N2O4, which is gas, to give 2NO2. The equation, the energy change shows that the reaction is endothermic. Okay, what happens when the temperature? What happens when the temperature is reduced at equilibrium? What happens when the temperature is reduced at equilibrium? Remember, according to Le Chatelier's principle, O, increasing the temperature, since it is an endothermic reaction, increasing this temperature, increasing the temperature will favor the forward reaction. Since it is endothermic reaction, increasing the temperature will favor the forward reaction. That is, the equilibrium will shift to the right. That is, more of NO2 is produced. But on the other hand, decreasing the temperature, what happens? Decreasing the temperature of an endothermic reaction like this one, the equilibrium will shift to the left. That is favoring but an exothermic reaction. So what happens when the temperature is reduced? If the temperature is reduced, it's going to favor but an exothermic reaction. In that case, more of N2O4 is going to be produced. So if we look at our answer here, the concentration of N2O4 increases. The concentration of NO2 increases. NO2 reacts with this. No. C. A colorless liquid is obtained. No. The pressure exerted by the gas increases. Our right answer is supposed to be A. The right answer is A, because decreasing this temperature or reducing when the temperature is being reduced, and since it is an endothermic reaction, what happened is that it's going to favor by the exothermic direction. And the exothermic direction is more of N2O4 is going to be produced. The equilibrium will shift back to the left, as I've explained here. Once more, being an endothermic reaction, increasing the temperature favors the production of more NO2. Equilibrium shift to the right. Reducing the temperature favors exothermic direction. Production of more N2O4 is an equilibrium shift to the left. So our answer is our answer for 24 is A. Our answer for 24 is A. 24 is A. Okay. 24 is A. 25. An oxidizing agent can be defined as acceptor of oxygen, a donor of ion, an acceptor of hydrogen, and a donor of electron. An oxidizing agent, what it should be remembered that an oxidizing agent is it donates oxygen, it accepts hydrogen, it gains electrons, it is reduced in a redox reaction. So here, looking at our answers here, our oxidizing agent will do what? Our oxidizing agent will be, it does not accept oxygen, it does not donate ions, but it will accept hydrogen, acceptor of hydrogen. So our answer for 25 is C. Our answer for 25 is C. Let's go for 26. 26. What is the value of x and the y in the equation below? Okay, if you are going to balance this equation, that is manganese 7 ion, acidified manganese 7 ion plus ethane diode, that is ethane diode. Here we will have x and the y. X for carbon here is 10, carbon here is 10. In order to balance carbon here, we need 2 times a particular factor, 5. So yes, that is it, 5. Okay, for hydrogen here is 8. So hydrogen is 2 times 8 is 16. Hydrogen here should be 16. And in that case, our answer will be C. 26 is C. I will do more discussion here at the end of the question paper. So question number 27. Which of the following is a good conductor of electric current? Good conductor of electric current. That is the one that can ionize very well. The one that can ionize very well will conduct electricity. So now, a mixture of petrol and kerosene, 0. B, aqueous solution of sugar, 0. Does not ionize very well. C, a mixture of ethanol and water, will not do. There's no full ionization here. D, aqueous solution of table salt. Table salt is sodium chloride. Table salt is sodium chloride. So this one will ionize very well, and for that purpose, it's a good conductor of electricity. 27 is D. Let's go to 28. 28. Meta P will be above meta Q in the reactivity series of P. Meta P will be above meta Q in the reactivity series if P A has a higher relative atomic mass than Q. No, 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 no. If P displaces ions of Q from solution, exactly. And in the reactivity series, the metal up will displace the one below. So metal P will be above metal Q in the reactivity series if P can displace ions of Q from solution. So our answer is B. Our answer is B. Question number 9, 29. Which of the following conversion involves electron gain? Which of the following conversion will involve electron gain? Potassium ion to potassium, a potassium solid to potassium ion. In solution, what happens? This one is a metal, is going to lose electron, and that's why it loses electron and it has a plus charge. So it is not electron gain. Okay, magnesium is a metal too. What will happen with this? In solution, the metal the magnesium metal is going to lose electron or loses 2 electrons to obtain a full octet of electron. So it does not involve electron gain. Ion 2 to ion 3. In solution, it has lost 1 electron again to be ion 3. So it does not involve electron gain. Copper 2. Copper 2 in solution. Copper 2 in solution is an ion. For it to be reduced to copper solid, it means it has gained electron. If it gains electron, electrons are negatively charged. So it will gain 2 electrons. These 2 electrons will cancel out 2 plus. Electrons are negatively charged, so it will be 2e, or it will be 2 minus. So when it gains 2 electrons, or 2 minus, the 2e or the 2 minus will cancel the 2 plus. And that is why it is ion copper solid. In this case, we say this is the only equation that involves electron gain. So our answer for 29 is D. Now we want to go further again. As I said, I was going to do some little work on, before we go, a little work on question number 20, question number 26, on this redox equation. You will see that this was a redox equation that was given. The redox equation that was given, we said manganese acidified manganese 7 ion in an acidic medium was reacting with ethanoate, not ethanoate, ethane diode, and now to produce manganese 2 and carbon dioxide. Let's see how we can get this full equation to confirm our answer of C. This is a redox equation. Being a redox equation, I said, in order to write this redox equation, you must know which one is being reduced. From this equation here, to know whether manganese is oxidized or is reduced, what happens is that you have to calculate the oxidation number of manganese here. Manganese here, you calculate it by saying that it is manganese, oxygen is -2. So it is -2 times 4 is -8, which is all to equal to the charge, which is -1. So Mn, which is manganese, when you carry this on the other side, is going to be positive. So -1 plus 8 is equal to -1 plus 8 is going to be plus 7. And that is why we say manganese is, plus 7. Manganese is plus 7. We go again. The same thing. The charge on an atom, the charge on an ion is the oxidation number. So manganese has been reduced from +7 to +2. That's why we are saying reduction. Now, in order to balance this, to balance the oxygen here, we will balance the oxygen here on this other side with a molecule of water. This is a molecule of water. We will balance it with a molecule of water. Now we have balanced the oxygen. Now the hydrogens. We can only balance the hydrogen on the left with an ion. We can only balance the hydrogen on the left with an ion. Let me not even do it there. Okay, now we have done it like that. That is the situation. Let's go to writing our full equations now. For this reduction equation, we say we will balance. The oxygen with a molecule of water. This is plus water. Now there's hydrogen here. This is hydrogen. The water here. How many water molecules are here? There are 4 water molecules, so we have to put a 4 here. There are 4. Now we have to balance the hydrogen, and the hydrogen is only balanced using what? Using hydrogen is only balanced using a proton. So we'll use plus a proton. That is hydrogen ion. Now, there are 8 hydrogen here. 2 times it, there are 8. So what do we do here? We need to put an 8 here. That one is okay. That one is done. That one is done. Now, what we need to do is, let's go to the second equation. Calculating the carbon here, it is using the same method of calculating the oxidation number. Carbon here is +3. And the carbon here is +4. So there's what? There is oxidation from +2 to +3. An increase in the oxidation number is what we call oxidation. So now, we use that to write our equation for oxidation. Let's write our equation for oxidation. Writing our equation for oxidation, we will have, there is carbon here, there is carbon there, and there's carbon dioxide. What do we do? The carbon is there, there's carbon here, and there's oxygen. We need to balance the oxygen. Oxygen here are 4, oxygen is only 2. So what do we need to do? We need to put a 2 here. We put a 2 there. 2 times 2 is 4. That is the oxygen, and everything is balanced now. Everything is balanced now. Now, the next stage to balance our equation is, let's see, since we are balanced, let's see if to balance the charges. Now, to balance the charges, what we need to do in balancing our charges right now is, let's add up the charges up and see. Okay, here we have only +2. Here we have only +2 that is there. We have only +2. We have only +2 here. So now, here, we will balance the charges using electrons. So here, there's the plus here is +1. A -1. 8 times plus, there are 8 pluses that are here. The 8 pluses and 1 negative is what? Is 7 plus. We have only 7 plus there. 7 positive that are there. Now, we have 2 positive here. In order to balance the 2, we have to reduce this one to be 2. So in order to reduce this one, we must balance it with electron. We must have like 5 electrons. Let's add 5 electrons here. Plus 5 electrons. Plus 5 electrons. We are adding 5 electrons here. So this is plus, this one plus this is +7. +7 plus 5 minus. Because electrons are negatively charged. Electrons are negatively charged. So 7 minus 5. Because electrons are negatively charged. So it is +2. +2 here and +2 equation here is balanced. Now let's go down. Let's go here for the oxidation equation. For the oxidation equation, what do we do to balance the charges? In order to balance the charges here, we have two negative here. We have two negative here. In order to balance the two negative on this other side, what do we do? There are two negative on this other side, so we must put two negatives on this other side so that we can balance our equation. So we must put two electrons. There are two electrons on this other side. Okay, can we cancel out the electrons so that we can write our full equation? We have 5 electrons here, and we have 2 electrons in this other reduction equation, or oxidation equation. So in order to balance the electrons, to cancel out the electrons, we need to multiply this by a factor that will be equal to the factor down. So this is, let's say this is an equation 1. So this will multiply this times 2. This is times 2. I will say it as equation 1. This is times 2. This is equation 1. And since in order to multiply this 5 times will be 10. So we will multiply this times what? Times 5. We will multiply this times 5 to get 10. Times 5. And this will be equation 2. So if we multiply this times this, what will be our product here? So it will be 2. It will be 2 MnO4 minus plus 2 times 8 ions will be 16. It will be 16. 16 hydrogen ions. 2 times this plus 10 electrons. Plus 10 electrons. To give 2 times this will be Mn. It will be times 2. Okay, 2 Mn 2 plus 2 times 4 here will be 8. 2 times it will be 8 water. That will be equation 2. That is, let me just say it is still equation 1. Equation 1. I'm still of equation 1. Okay. Now, let's go to oxidation equation, which is equation 2. We are multiplying everything here by 5. So here it will be 5. 5 times this will be 5 C2 O4 2 minus to give 5 times this will be 10 carbon dioxide plus times the number of electrons, 10 electrons, and that will still be equation 2. Now we want to have our total. In order to cancel out our electrons, let's cancel out our electrons. Okay, the 10 electrons here will cancel out in equation 1. We'll cancel out these other 10 electrons here. We'll cancel out this. Now we write our full equation. Our full equation will be equation 1 plus equation 2, which will be equation 1 plus equation 2. It will be 2 MnO4 plus 16 hydrogen ion plus, for the reactants, plus 5 C2 O4 2 minus to give the product, which will be 2 MnO2 plus 8 water plus 10 carbon dioxide. That is our equation. Now, that is the equation we were given in our equation. So this was X and Y. How many of these of hydrogen ion are reacting with this? And that is how we had our answer. That's how to show that our answer we got on question 26 was 16:5. That is how you can write a redox equation, half equation. So thank you very much for listening. We are very grateful for the time you have taken for this. Once more, for those of you who haven't subscribed to our channel, please like this video, share to other learners, and most importantly, take some time to subscribe to our channel so that subsequent papers that we are going to be solving will come directly to you. Thank you.